I'm down for a sketch of a graph. What do we want to do on this graph?
So we have the measurements of the two vectors that we need. We have the angles and magnitudes both vectors, so we write those.
Yeah. You know what? Maybe to keep it from getting messy, we'll write them separate. Do this on Delta Math?
Huh?
Do this on Delta Math?
Yeah.
Delta Math's gonna have a word problem like that? Especially in the structure. So we have, this can be our blue. I don't know how well you guys can read it. It's at 58 degrees. That's probably a little more, but that's fine. And with a force of 135. And pulling with 214 at 43. So we have the magnitude and the angles. And it wants to know the total, aka it's going to want this green when you put them together. All right? You have one force and another force together. Putting them together is the resultant of the two. Well, how do we find that dang green arrow? Just because it's green? You think Kermit just knows everything about green arrows? No. I'll stand for a little bit. That's all we're doing today. Till maybe an idea sprouts in someone's brain. Yeah, add the vectors. How are we going to add them?
You have four numbers there, just pick two and add them together. So we do 214 over 135.
For using trig, we need a specific kind of triangle. Oh, that don't look right. Oh, but hey, that's a step in the right direction. We need a right triangle. I bet there's some right triangles I could make.
You gotta draw the line down. Draw the line down from the top. There you go. Like one.
Okay. How does that help us? I'm gonna get rid of this.
We only have the given angle and a 90-degree angle. Figure out the last angle. Wait, are you doing the 43 one? You're right.
Yeah. It's a little exaggerated. It's 43 degrees versus 58. It's not gonna be. It's like I took this and. I mean, they kind of look the same because I suck at drawing, but that's fine. What? No. Someone might have said it and I wasn't listening to them of ideas, but. Oh, we need the triangles. Yeah. Triangles are going to help us. I'm asking how. We need just keep in the back of your mind. We need this green guy. Yeah, but the problem is once we stack that red guy here, that's not a right triangle. Maybe I don't want to do something that'll give it completely away. That is the entirety of this class, pretty much. You use trig. Does that help us think at all? We got two triangles. Hey, any vector is made up of two components, which are, yeah, that's true.
1, 0, and 0, 1. The X and the Y.
The X and the Y. How can I find the X of the resultant vector? If I find the X here and the X here and put them together. Right? How can I find the Y of that vector? Yeah, get the Y values of each of them. And how do we do that? Trig on the right triangles, which we need. Okay. So, maybe x1, y1. To find x1, we want to deal with the 135 and the x1 with the 58 degrees. And if you have physics, you may have done this. Sine, cosine, or tangent? Oh, you're just throwing.
Well, there's always three options. Eventually, I'll get it right.
My specific question is I want to find x1.
Yeah, oh, no, I guess cosine.
Equals adjacent SOHCAHTOA over hypotenuse. $135 times the cosine of 58. Hey, if you use these on your little Chromebooks, it all starts out in frickin' radians. So make sure you mode it and go to degrees. $71.54. I'll circle this so I can come back to it. Okay. Now I want y1. Which one am I going to use? Opposite hypotenuse. Sine. Oh! And wait, who has physics again? Have you guys seen the cosine is x and the sine is y? That's kind of how it is in the unit circle as well. So, I mean, you have to times it by the magnitude. You guys haven't done vectors in physics yet?
Yeah. We're doing those body diagrams. Oh, yeah.
I don't know what gets covered in physics here, by the way, so.
Oh, we're going.
Circular motion. Maybe you'll use some linear and angular velocity. Oh, now we better do it for the other one. Too bad. Getting tired of this, Grandpa. Alright, I'll call it X2 and Y2, I guess. So maybe I'll... $43 and $214. This was our triangle. To find X1, oh, by the way, the expectation is that even though delta math won't have a problem like this, that we'll be able to do this. Right? If we're given two vectors, that we'll be able to add them together, even if it's not just in that nice little component form, right? If we could add them like this, that was great as well. And then sine of 43 equals y2. I put x1 there. It should be x2. Equals y2 over 214. $145.95.
Wait, serious question.
Yeah.
So when we take a quiz or test,
Yeah.
state one, is this stuff still gonna be open?
Yeah. Okay, well now the total x component, if I went that far to the right and then I went that far to the right, you just add them. It's only 1.54 plus 114.49. So our x component, from adding those two things together, 186. This is our green guy, the guy we wanted the whole time. And the y component is going to be if we add the two. Oh, wait, that's wrong. I added the wrong number. I added that guy. Wait, did I? I don't know what I did. I'm just going to do it again. 71.54 plus 156.51. I absolutely did add the wrong one. I add the two x components together. And now we're going to add the two y components together. There's our vector. So what we wanted all along, right? If we add the x's, that's going to give me the total x. If we add both the y's, that's going to give me the total y. What is the magnitude of the force exerted on the stretcher? Well, this isn't a magnitude, is it? That's saying we go 228.05 this way, and then 260, clearly not drawn to scale. Went 44 up that way. So then the magnitude is this guy. Oh, Pythagorean theorem. The square root of 228.05 squared plus 260.44 squared. 346.17. Oh, there's our magnitude. Oh, hey, I want to do something else too, because usually vectors aren't just what's the magnitude. Vectors are magnitude and direction, right? So can we can find this angle, can't we? Why did I leave a giant space there? So I'm looking for theta. If I'm looking for an angle, I better take an inverse. Oh, chapter 5. Quick, everyone, what's the tan inverse of 260.44 over 228.05? Make a triangle. Or remember it from your table. I'm joking. I'm so funny. Why didn't anyone laugh? No! Oh. So now the total force on this lady's stretcher, bless her heart, hope she's alive, is 346.17 newtons at 48.79 degrees. Kind of useful, or useless when you're talking about a lady on a stretcher, but maybe more useful in other areas. That terrified me. Well, that's all I got for today. I thought we'd work through that. So you know, if I give you two vectors like that, the delta mass doesn't really have stuff like this. You better be able to put them together. That makes sense though, right? X component and the other X component is going to make the total X component, Y component, and the other Y component. It's going to make the total Y component.